Problem 4 wants us to determine the limit as x goes to negative infinity of 3 times the absolute value of x minus 4x over 2 times the absolute value of x plus 5x. So just like anything else we do with absolute value, we have to remember first and foremost that this is a piecewise function. We also know what the graph of the absolute value of x looks like, right? It looks like a V. So on its left side and its right side, it's growing to infinity. So if we just try to think of this conceptually, we kind of have some kind of infinity minus infinity in the numerator and infinity plus infinity in the denominator. So what does that even mean? This is why direct substitution does not work at all for these types of problems, because how do you determine whether this is 0 or infinity? And I can tell you for a fact that you cannot assume infinity minus infinity is automatically 0. So we need to do some rewriting, and we need to remember that absolute value of x can be written as a piecewise function. So the absolute value of x behaves like x when x is to the right of 0, and it behaves like negative x when it's to the left of 0. So if this limit is to negative infinity, we are definitely looking on the left side of this graph. So every absolute value we see will behave like negative x. So that means I can rewrite this limit and replace every absolute value of x that I have with negative x. Notice that the 4x and the 5x, that was just x by itself, so you leave it alone. Now I can actually simplify this, and negative 3x minus 4x is negative 7x, and in the denominator I get negative 2x plus 5x, which is 3x, and the limit of this is negative 7/3 because my x's will cancel. Part B says, well, let's look at the limit as x goes to negative infinity of negative 6x plus 1 over the square root of x squared minus 4. So this is also an indeterminate form of infinity over infinity, because the negative 6 times a negative infinity is going to blow it up to positive infinity, and the square root is going to blow up to positive infinity as well. So we need to do some more work to figure this problem out. So we're going to use the fact that the square root of x squared is the same graph as the absolute value of x, and that behaves the same as negative x when x is less than 0. So because we're looking at negative infinity, right, I could have just replaced absolute value of x with x squared. So it's sort of the same idea. It's going to behave that way. Now, I can't make a direct substitution like I did with the absolute value of x because this is structured a little bit different. The x squared is trapped inside this radical, so I need to do a little bit of rearranging or scratch work first. So let's take the radical itself and rewrite it so that I can use this important fact. So the first thing that I'm going to do is I need to isolate the x squared out of the expression. So in the similar way in problem 1 where I factored that negative x cubed out front, I want to factor an x squared out of this expression. So when I do that, I get 1 minus 4 over x squared. And then by properties of radicals, I'm allowed to say, well, that's the same thing as the square root of x squared times the square root of 1 minus 4x squared. Now that this is all by itself, now I can substitute negative x like I did in the absolute value of x problem above. So now this denominator is actually going to behave like this as we go to negative infinity. So if I go back to my problem, I'm going to rewrite my limit with my new substitution. So the denominator will be negative 6x plus 1 over, or the numerator will be negative 6x plus 1 over my new denominator of negative x times the square root of 1 minus 4 over x squared. Now I'm still in an infinity over infinity situation here, but I can invoke my powers limit, and I see that the highest power of x in the numerator and denominator is just 1. So I can actually multiply this by 1 over x over 1 over x. So now I get the limit as x goes to negative infinity. In the numerator, when I distribute this across, I get negative 6 plus 1 over x. In the denominator, I only since both of these terms are being multiplied together, I just need to multiply it by this, and I get a negative square root of 1 minus 4 over x squared. So this x cancels this x. Now I can evaluate my limit. My numerator is negative 6 plus 0 over the square root of 1 minus 0. So this overall limit is just negative 6.